Welcome to Feature Fridays. My name is Guy Bartram. I'm Director of Product Marketing for our cloud providers in VMware. And today, joined again by Nikolai. Welcome back, Nikolai.
Thanks, Guy. Hello,
Why don't
everyone.
you give everyone a quick introduction? What do you do for those who haven't seen you?
Sure. My name is Nikolai Patrikov, and I'm a senior technical product manager at VMware. I'm mostly responsible for the DRS solutions and VCDA or VMware Cloud Director Availability in particular. And today I'm going to present you how to use VMware Cloud Director Availability together with some more VMware tools to perform ransomware recovery.
Yeah, great. I mean, this has been something that's been asked for a long time from our cloud providers. We've obviously had VMware Cloud disaster recovery as a solution. And that's now recently kind of brought out some fairly compelling ransomware recovery use cases. But that's a SaaS solution. And, for our cloud director providers, they obviously can't use that, with Cloud Director. So today we're going to talk about, what is available with Cloud Director availability and looking at Carbon Black, right? I mean, Carbon Black is a SaaS product available today to our cloud providers to use and consume. And compare, when it's put together with Cloud Director availability, we've got a pretty decent solution for ransomware.
Yeah, and of course, this is our recommendation, but any other tool can be used for detecting the ransomware threats. So we have a white paper that is published with all the guidance and how to use all these products together as our recommendation. But yeah, it can be any other tool as well.
Okay, cool. So yeah, just let's just rewind a little bit. So VCDR, which is the SaaS solution, is very closely coupled with cloud VMware Cloud and AWS. I mean, it really requires VMware Cloud and AWS as a restore kind of target
Hmm.
and uses S3 object storage. So that's quite a challenge for cloud providers who are using Cloud Director today. So Cloud Direct availability, what we're at, was it 4.6 now?
Yeah, it's 4.6.
Yeah, and there's some fairly cool functionality in there today, and we've got a very large number of our Cloud Director partners using this solution and providing DR and migration. But specifically, what around ransomware? What's the kind of the requirements that you kind of see service providers asking for with Cloud Director availability?
Well, the biggest one is to have their existing infrastructure based on Cloud Director and NSX to be utilized. And for that, Cloud Director availability is the perfect tool because it's natively integrated with Cloud Director and with
Mm.
its organization structure, with its multi-tenancy. So it makes it very easy and very smooth to use Cloud Director availability with Cloud Director. And with the existing set of automation and what they have to provision their tenants, like organization resources, networks, edge gateways, etc. Cloud providers can complement this ransomware solution that we are proposing and can make it even better. And they can use whatever they already have. This is the best thing. So it's just adding some small things on top of the existing infrastructure without requiring any major change and without requiring any external infrastructure like what we have with VMware Cloud on AWS.
Okay, cool. Well, let's dive into it then, Nikolai.
First, what are the products in scope that we have? Of course, Cloud Director. It provides the multi-tenant infrastructure for the cloud provider and for their tenants. We have Cloud Director availability that gives the disaster recovery piece. NSX, it is providing the general networking, the firewalls, and everything that is required for network isolation for testing the different instances. And our suggestion is to use Carbon Black Cloud for threat detection and for identifying which instances of workload are infected and which are not infected yet and can be restored back to production. A high-level overview of the solution. So it's the general solution that we have with Cloud Director and Cloud Director availability. So for cloud providers who already offer DRaaS using Cloud Director availability, they can use whatever they have already set up, and just with some small adjustments in terms of creating the right isolated networks and etc. They can enable this easily for their tenants, their existing or their new tenants. So it's something very minor as a change from the typical infrastructure. We introduced Carbon Black Cloud, that is the service for threat detection. It's accessible through the internet. And we have some additional details on the different ways to connect to the instance. And here is one important thing to mention. I have a dedicated slide on that, but with Carbon Black Cloud, there are two options for using it: with a single organization or with multiple organizations. And based on how it is consumed, we can provide self-service to tenants or managed service. So it's based on Carbon Black or on the threat detection solution, and whether it has a tenancy model in order to align it with the Cloud Director tenancy.
Okay.
So yeah, in terms of infrastructure, we have the SDDC, we have all the management components like NSX, vCenter, of course, usage meter for metering, all that, Cloud Director availability, and its typical setup with multiple replicators. It can have one or two tunnels, depending. This is one of the new features in 4.6 to support high availability for the tunnels, and the replication management appliance as well. And with that, it's a very typical setup, I would say. With VCD as well, we don't require anything additional there to be deployed. And our example is with an on-premises data center, but of course, this is applicable also for another Cloud Director site with the same infrastructure, the same destination infrastructure. So it won't change for the cloud provider if they have two Cloud Director sites and want to perform this disaster recovery from one site to the other. So it's pretty much the same thing.
Okay.
What needs to be prepared? So we have a set of suggestions for cloud providers, and as I mentioned, everything is documented in our white paper that can be found in our blog. I have a dedicated blog post on that. First, we start with creating some routed networks and defining the subnets that will be used for testing the workloads, and then applying the necessary firewall rules to restrict these routed networks and these subnets, so they cannot access anything but the specified resources like sensor gateway or file server or DNS, whatever we have as part of the setup, depending on the configuration. We need to set the Carbon Black. If we use the multi-tenant Carbon Black setup, we should create organization for each tenant that would like to have the ransomware recovery service. Also create one or multiple policies within Carbon Black for how the sensors will react to detecting an infection. All this is controlled, and it's a mandatory thing. So we have it in Carbon Black, and I have an example, of course, for that. It's important to always maintain the latest installation kits for the sensors that can be installed on the workloads. They are refreshed regularly by the Carbon Black team, and they can be easily downloaded from the cloud service. Also, since part of the process is deploying these sensors to the tested workload to the specific instance, we need to distribute these together with VMware tools if it is not already deployed on the VM. We need to distribute. We have a few suggestions. First, and probably the easiest one is to bundle them into an ISO file and load it to one of the content libraries. We can even make it per tenant with some scripts for automating some of the tasks. I have my demo with an example of that. And this way you can further limit the access to external services like file server. The other option is to use a dedicated file server where each workload can access and can download the bits. Mm-hmm. And of course, there are several other options. Here we are leaving it open to the cloud provider and to whatever serves best for them. Deploying Carbon Black Sensor Gateway. This is not mandatory. It's an optional step, but it definitely simplifies the whole setup and the whole topology. So we highly recommend using this approach. With a sensor gateway, you don't need each VM or each instance to connect directly to the cloud service. It connects to the sensor gateway, and through the sensor gateway, all the scan information is delivered to the cloud service, Carbon Black Cloud Service. Right. So it simplifies the setup. And of course, if we prefer not to use a sensor gateway, then we'll need a dedicated DNS server that will be used for resolving mostly the Carbon Black cloud service FQDN. Yeah. So it can be a very simple setup for that.
So just so defining those steps, then there's the routed network segments and DF rules. These are basically so that the tenant can connect to the Carbon Black gateway or Carbon Black Cloud, sorry, and download all of the past data. So if you don't do that, you'd use the gateway. That seems like a no-brainer, right? Is there a reason why you wouldn't use a gateway?
If the cloud provider doesn't want to spare additional resources, it's not such a big VM, but probably they would need several of them if many tenants would use. So for me, this is the only reason that somebody might not want to use a sensor gateway.
Okay. And the other piece here is obviously accessing the Carbon Black Cloud itself. Is this something that tenants are going to have to re-authenticate to when they actually, because this is a separate UI, right? This is a separate solution to Cloud Director. Sure, you could put a link in Cloud Director to, the Carbon Black Cloud login, but would they have to maintain login credentials there as well?
Yeah. So here is the thing about the multi-tenancy. If the Carbon Black Cloud is used as a single organization, then there is no option. Of course, cloud provider can provide credentials to the tenants, but they'll see the resources of all other tenants. So this is the managed service that I mentioned. It won't be possible because of seeing other organizations' information. And if Carbon Black operates in multi-tenant mode, then each tenant will have their own organization and can get credentials with the right access level for this organization. And they can open the Carbon Black UI to verify the scan results, or they can use the API. I have a few examples with the API, how this can be further automated and simplified. But for in this case, they can use it and they can perform everything as a self-service.
Yeah. Okay. So it's Carbon Black is either Carbon Black Cloud could either be a fully managed service, like you said, service provider sees everyone, or it's more of a kind of multi-instance based where you set up an instance for an organization and that organization can see only their VMs and their rules that they've got applied against policies and stuff. So, and is there any linkage with identity and access management for a service provider to kind of pass the credentials to log into Carbon Black Cloud from the credentials they're managing for Cloud Director today already? Any multi-factor authentication integration, for example?
I think it is available, but I haven't explored this option so far, so I cannot fully confirm it.
Okay, no problem, no problem. All right, that's cool. And the only other question I had is obviously there's the DR. There's the recognition of ransomware has happened, and then there's the kind of recovery actions, taking an image from the DR kind of library and testing that image. Does this setup here or help automate that into a secure org structure, or is there a separate setups done by a Cloud Director availability to provide that SAM pit so you can spin up a VM securely?
The first level of securing it is creating this dedicated network segment with defined subnet and limiting its access to others through firewall rules. Of course, there are additional options that can be used, having a separate org VDC only for that is independent, having placement policies within VCD and ODs, instances using the placement policies to be placed in a special org VDC again. So there are additional things that can be done, and some of them can be configured through Cloud Director availability. Like you can select the placement policy while testing the failover, and you can select the destination resources like the org VDC. So you can configure that as part of the process through Cloud Director availability.
Okay, great. Thanks, Nikki.
Yeah. So here are a few examples for firewall rules. I won't spend much time. Depending on the setup, we can have different set of rules for connections, how it looks in NSX, where I have configured that. An example of a Carbon Black policy that I mentioned with all the actions taken depending on a threat detected. How it looks to obtain the registration code. This registration code is mandatory for registering your sensor to a sensor gateway or directly to the cloud. So this is something that if it is a multi-tenant Carbon Black, the tenant can obtain their code by themselves from the UI. If not, the cloud provider should provide that. And it can be, of course, part of the automation. I have a very simple script created, and it's part of my demo where it downloads the sensor bits and installs the sensor and registers it, having the registration code within the script. And if you provision ISO file per organization within their catalogs, it can be all included there, so it can save a lot of time and effort to the tenant having everything in there, like one-time provision by the cloud provider. So there are many options, but it's a mandatory step to obtain this registration code. The installation kits, again, this is how they look in Carbon Black UI, where they can be downloaded, and depending on who has access, it can be the provider who downloads the latest and updates the media in the content hub, or the tenant doing all this as part of a self-service and self-servicing themselves.
Yeah, and can that be automated? Because that's obviously quite important to keep the latest sensor kits.
Currently, I didn't find a way, but I guess there should be some option for that. Okay. Maybe checking a repository from the UI. We don't have this automation, but probably there is. I'm not a cloud Carbon Black.
Yeah, no worries.
Expert, and this is why some of the questions are a bit difficult for me. But yeah.
Okay.
In terms of tenant prerequisites, what I mentioned, they need to acquire the company ID, the registration code, install the VCDA on-prem appliance in their data center, of course, to protect their workloads. This is very important. And to install and maintain VMware tools on the protected workloads. This is recommended, not mandatory, but it's important for the whole process. So at some point, VMware tools needs to be deployed to the tested instance. So it's better to have it prior to that.
Yeah.
The deployment of the solution. So we have two scenarios. One is with sensor gateway and one is without. It's quite simple. So we have the tenant org VDC in this example and a dedicated network segment for attaching with its subnet for attaching these ransomware infected instances to be tested. We have all the other workloads aside. They are still in this OVDC, but they're unaffected from this whole process. And here is one of the great features of Cloud Director availability. You can specify different network and guest customization settings for testing and for actual failover. So for test, you can use this dedicated and isolated segment. And for failover, you can configure settings for placing the failed over VM into another network segment with completely different settings, which means once you find a non-infected instance of the VM, you can immediately fail it over and make it operational within another segment with your other production workloads in the same cloud. And from there, you can migrate it back to the on-prem data center, or you can leave it running until you need it in the cloud.
Yeah.
So with that, we have the shared services that we call. It's not mandatory they share the same network. They should, of course, have all the routing in place to be able to access the different components. But we have the Carbon Black Sensor Gateway, the file server, which is totally optional, as mentioned, and the Cloud Director availability was the Carbon Black Cloud. So from the sensor gateway, we must provide connectivity to the Carbon Black Cloud. Without sensor gateway, pretty much the same topology. It looks exactly the same. The only difference is instead of the sensor gateway, we would need a DNS server or a proxy that would be used by the VMs in the restricted subnet to connect to the cloud.
Is there any processing requirement? If you've obviously got the sensor gateway locally, is it faster to process the rules that are being applied? So I don't know how Carbon Black actually does the processing. I'm assuming it does it all in Carbon Black Cloud, but the sensors have these packages that kind of scan for specific things.
Yeah.
So would it be faster to have the sensor gateway or a DNS, or does it make no odds?
I think it won't make much difference because the sensor is operating locally on the VM and then sends all the results through the gateway or direct to the cloud. So it would be maybe some milliseconds or seconds depending on the transfer rate, but it won't be much of a difference.
Okay.
Okay, the recovery flow and how it happens. Here I have marked everything marked in green can be performed as a self-service without any restrictions. And what is marked in blue is dependent on the tenancy model of Carbon Black. So we can see the majority of the steps can still be self-service, which means even if the Carbon Black is a single organization, it can be some kind of a hybrid half self, semi managed service for the cloud providers to offer, not fully managed. They can leave part of the process to their tenants, like for example configuring the protection by themselves and just participate in testing and verifying the instances. So there are plenty of options here, and each cloud provider can define and use what works best for their case and for their resources, because if it is a managed service, it would require resources, of course, to operate it. So the flow and how it begins with protecting your critical workloads with the right recovery settings. Depending on the criticality of the workload, you can use different settings. Here, cloud providers, most of the cases, provide the so-called SLA profiles that can be applied. Sometimes they leave it completely to the tenants with using custom settings like RPO and number of instances, how many of them can be stored, etc. So these are the options here. They can make an SLA profile, especially for ransomware recovery, with what they observe best practice for storing, like retention policy for instances. How they can spread the maximum number of instances that can be rotated is 24, supported by Cloud Director availability, so they can spread them differently in time with using the advanced retention rules, up to 5 rules. So they can make a combination that would guarantee that at least a very old instance will be always preserved and will be able to restore it if you don't find any more recent that is not infected. So after you configure this, Cloud Director availability starts creating instances according to these recovery settings. And once ransomware is activated, the process, and here is one important thing to mention here. At the moment, it's quite a manual process. It can be automated, some stages of it using API calls, but it's not fully automated, like you mentioned, Cloud Disaster Recovery, which is a great product, and they have majority of these operations already automated within their UI. And here we aim with Cloud Director availability to include more of them in natively in the product. But for now, what we can offer, and this is why we dedicate a whole white paper on it, it's mostly a manual effort to get there. So after we have ransomware activated, we pick an instance, recover it, deploy VMware tools if it is missing, and the carbon black sensor. Here we can use some automation. Run a background scan. This can be performed through the API or through the carbon black UI. It works both ways. Check for any ransomware alerts generated. If there is any, it means this instance is infected. If it is infected, we uninstall the sensor and remove it from the carbon black UI, just to avoid confusion in the future. Perform a test cleanup, which is a single click of a button, also can be done through the Cloud Director Availability API, and start with the next instance. And we perform this until we find a non-infected instance. Once we find it, we can uninstall the sensor, perform test cleanup, and immediately after the cleanup is finished, we can fail over this specific instance. We can store or delete an instance manually through the Cloud Director Availability UI, so we can delete all the infected, not to take storage and pay for them while they are not useful at all. And we can store this good instance or good instances, fail over one of them to the cloud, and optionally migrate this working VM back to the on-premises data center, again using Cloud Director Availability with minimum downtime. As we know, the migration, the warm migration that Cloud Director Availability supports has very minimal downtime, like graceful restart of the workload in terms of time.
Yeah, I think it's worth also pointing out here that what we're talking about here is a disaster recovery for a ransomware infected workload. I think people are getting really confused between like backup and restore of a particular data set or a VM. This is slightly more kind of robust in that this is the last resort, right? I mean, you've gone through your backup recovery kind of mechanisms and seen there's infected machines or files that you need to clear out, and you need to go further back, perhaps. But I think it's important to talk about the fact that this is a disaster recovery workflow, and that is actually a little bit more different than a normal kind of backup and restore type operation.
Yeah, it's a bit more different, and is utilizing the full capabilities of Cloud Director Availability, which is not a backup tool, but a disaster recovery and migration tool.
Yeah, exactly. Okay.
Okay, the same flow, how it looks in terms of timeline. Again, we know that typically there is some time interval between infecting with ransomware and it being activated. So here we start with protecting a VM, creating the different instances at the cloud provider cloud. And once we have the ransomware activated, our on-prem VM is not operational. We have the downtime started at this period. We start with the latest instance. We see that it's infected. We go with the next, until we find some instance that is not infected. In this example, it's N-2. We fail it over after the test is performed. We fail it over, which means the downtime can end if the tenant can operate and can use it in the destination cloud, doesn't use the cloud only for testing the instances, but also has other workloads and uses it for production. Or they can reverse it. In this case, it's not correctly using the term reverse because we are migrating, but in terms of the destination and how it travels between the cloud and the data center, it's reversed back to the on-premises data center, and it can start operate there immediately after it's being migrated there. And a few details about Cloud Director Availability and then Carbon Black. Here are the SLA profiles that I mentioned. They can be pre-configured, as in this case, with the target RPO, with multiple retention rules, or they can be configured manually if this is permitted to the organization through the replication policies. And then tenants can configure them on their behalf, and depending on how they prefer to store these instances. The recovery settings, as I mentioned, we have the different section for migration failover or for testing, and they can be completely different. They can be configured right after the protection is created. So it's not something that needs to be done for every test or for every failover. It can be a one-time thing. It includes the network adapters, how they'll be to which network they'll be attached, whether they are going to use DHCP, IP pool, static IP, etc. And we also have the guest customization that Cloud Director has as a feature. So everything that is available in Cloud Director in terms of guest customization, like computer name, resetting password, even executing scripts, which again can be used for some kind of automation. For example, for mounting the ISO file and performing the deployment directly using this, because the script can be executed directly on the failed over VM. So it allows to get creative and see how you can optimize the process. So all this is configurable. Then we have the test failover, which is the key operation, testing the instance. Once we test it, we can see it in Cloud Director, working VM, and we can operate with it. We can open the web console or whatever and start performing the rest of the operations. Storing and deleting instances, it's done through the UI. So we just pick an instance and we can either delete it or store it. A stored instance can be unstored after that if we find a better match for our needs. And here, just an example of how a device looks in Carbon Black once it is registered with its name and sensor, everything available, the details for this device, an example alert. So this is how it looks in the UI. Of course, we can get this information from the API as well. So in terms of Carbon Black, the API offers great options. So the operations that we mentioned in our flow all can be executed through the API as well.
Yep.
And here are the automation ideas. The Carbon Black API, searching for a device based on its IP or the sensor gateway that it uses to connect. So we have multiple options for filtering. Why we need to search for this to get the ID of the device and then start the background scan. It will start at some point automatically, but if we want to start it right after the test failover is completed, we can do this manually. We can search for alerts based on this device ID, and we can delete the sensor to unregister it from Carbon Black Cloud as well, and before performing the test cleanup. In Cloud Director availability, through the API, we can get all the instances for a specific workload, for a specific protection. We can initiate the test failover using the instance ID, and we can perform the cleanup for this test failover. What currently is not available in the API is to store or delete an instance, but I guess they will be part of the public API at some point shortly in time.
Yeah.
And now, after all the boring slides, let's get to the demo. So it's a recorded one to save some time of protecting and failing over the VMs, but I'll speak through it. I guess it would be still quite good. So first, the prerequisites and what I mentioned in that needs to be set up before. We have an org BDC with all the networks. I use this routed network, and it's defined subnet. I have all the IP pools, static IP pools to use, a DNS, and everything needed. Also on NSX, I have these firewall rules in the distributed firewall for allowing access to different services. Of course, they can be different depending on the setup. This is just my example with everything in there. The on-premises data center, it's a vSphere data center. This is what I didn't mention. The solution is applicable for vSphere or VCD sources. No other sources than that are currently not supported by Cloud Director availability. So we have a vSphere with a VM running here, fully operational VM, and it will be then protected. How to protect the workload, the whole flow, it's very simple. We have shown it many times, but once again, it can be done. Here we are showing the self-service process. It can be done directly through vSphere, through the Cloud Director availability plugin. that gets installed when we deploy the on-premises appliance. We go to outgoing replications, new protection, and here first we need to authenticate with the org credentials that we have in Cloud Director, and after we authenticate with them, we have access to the cloud resources that we'll select on the next step. We find the VM that we would like to protect. It takes some time because it's hidden somewhere there, but we select the right VM to be protected. The destination VDC and storage policy. This is what I mentioned earlier. We can have a defined and specified org VDC for ransomware recovery. We can select it here. Then the SLA profiles with the different retention rules. They can be customized after that if it is something that cloud providers would like to allow to their tenants. Also, the placement policy can be selected if it's present to place the VM on a specific org VDC in Cloud Director. Then the protection configuration process is happening. The initial synchronization, which creates the first instance of this VM. And the protection is ready. And the Cloud Director availability now creates instances according to the recovery settings and the retention rules. Now we'll configure these recovery settings. In this example, we won't configure the migrate failover, but just the test ones. So we select to which network will connect the VM, the network adapter, again, connecting it to the network, the IP mechanism, and the guest customization. The warning sign is because to have guest customization and any IP configuration changes, we require to have VMware tools installed and present at the VM. This is why I mentioned that at some point it's mandatory to get them, and it's better to have them prior to protecting it. And with that, we have applied the recovery settings, and we can proceed to the key step, testing the failover. We select the VM, click test. Once it loads, we can select whether to power it on directly, or if we want to perform any operations before powering it on, we can uncheck this. We can use the pre-configured settings that we showed on the previous step, or we can directly connect the VM to a network from here. If we haven't configured any recovery settings, again, the placement policy. And here we can pick which instance we will use for testing from the list of all available instances. After we do that, we just click finish, and the VM is being created and registered within Cloud Director. Once the test is done and we see the test image ready, now we go to Cloud Director, to the org VDC, and we can see we have the VM here with all the right settings. See VMware tools installed, the VApp name, what is the data store, etc. We can then observe also the network settings and its IP address. It's within the desired restricted subnet.
That was in the rooted subnet, right?
Yeah.
Not the isolated subnet, but it would be an isolated subnet if you wanted to do a test recovery.
Yeah.
Yeah.
Here is how we import the ISO to this VM, and then we can open the console, authenticate, and start performing the deployment of the sensor. First, we mount the ISO. We can see we have a script and the sensor itself. Now we'll execute the script that we have in TMP. So it also downloads the latest. I have included in it to download the latest version from a file server, so showing both options here, and deploys the sensor, registers it then to the sensor gateway. All this I have included in the script. It's quite simple, but just for example purposes.
Mm-hmm.
And once it is successfully installed, we can verify that it's successfully installed, and we can see it registered in Carbon Black in its UI. So far, no information because it was just registered. But after we perform some operations, here are my API examples. First, how we search for a device. In this case, I use the sensor gateway URL for filtering, so it will show me all the devices that are attached to this sensor gateway. In my case, it's just one. And we copy the ID of the device. Then with this ID, we can proceed to the rest of the operations. We can see all the information about this device. It's always shown like the full in the response, the full information. So we can always find it. We just use the device ID to initiate the background scan. We get the response 204. Everything's good, and the background scan is completed, is initiated. So it will take some time, but after that, we can just check again using the device ID. We can check for any generated alerts. In this case, I don't have any because I just started the background scan. But here is where the alert should show up. Then the test cleanup. We say, okay, this instance has no alerts, so it's a clean instance. Let's perform a cleanup and fail it over to the destination. Again, for cleaning up, we need to authenticate with the org credentials. And it's just simple cleanup. It will power off and delete the VM from the destination cloud that was created. So here now I refresh and the VM is gone.
Yep.
This is how the cleanup works. And we can then go to instances, and the one that we just tested, we can delete it or we can store it. In this case, I'll store it because it's a clean instance. Just click store. We can see the message that you can store permanently 5 instances per replication. This is configurable through the replication policies that you assign per organization. So each organization can have different limits.
Mm-hmm.
And the last piece is the failover. Similarly to testing, we just select failover. Same choices to be done here, whether to power on, network settings, and we can see the stored instance marked differently than the others, so we can easily find it, and we just select it and fail it over to the destination, then operate with it, use it, or migrate it back to on-premises.
Pretty cool. Pretty cool. I see there's So the cloud direct availability stuff is all pretty much standard. It's just test backup, test replication, test the instance, then cleanup or recovery. The integration of the Carbon Black stuff could be quite easily done through using golden images or whatever you want to do. So it's all pre-baked into the images. That could be nicely offered as a service then by cloud providers. A little bit of manual work in terms of creating the tenant org in the cloud solution itself for Carbon Black. But then pretty much, like you showed on the API, right, a lot of that could be just operated. In fact, cloud providers could create their own very small extension just to kind of provide that to tenants, like, here, test your image, select the image name, and off you go. It wouldn't be too hard to do that.
Yep. A lot of options for now that need to be done by the cloud provider, but hopefully we'll get also some feedback on that, and we'll be able to enhance VCDA to cover that and simplify it even further for both tenants and cloud providers.
Yeah, brilliant. All right, Nikolai, thank you very much for walking us through that and recording the demo. I know that was quite a lot of work to get all that kind of up and running, so appreciate that. The white paper is out this week, so I'll put the link below. Obviously, this kind of steps through kind of what we've covered today, but in more detail, right?
Yeah, exactly. With all the necessary details and considerations, notes, what needs to be taken into consideration when you define this or configure that. So yeah, it's quite detailed on the topic.
Cool. Brilliant, Nikolai. Thanks a lot for your time today. Really appreciate it.
Thank you. Thank you very much for inviting me.
Cheers.